The moon, our companion in the night sky, a symbol of romance, mystery, and cosmic violence. Beneath its serene glow lies a history shaped by countless impacts. From the scorching moment when it first formed to the craters we see today. Each scar tells a tale of collisions in the solar system. In this episode of Moon Impact, we explore how the moon's violent past continues to influence Earth and how future impacts might shape its destiny. Strap in for a journey through time, space, and consequences. Animations of early solar system, a young Earth and a Mars-sized impactor, striking debris flying. To understand the moon's impacts, we must begin at its birth. According to the leading theory, called the Giant Impact Hypothesis, about 4.5 billion years ago, Mars-sized body collided with the young Earth. Wikipedia +2 NASA Science +2 The force of that collision melted the planet's surface and flung vast quantities of molten material into orbit. Over time, that debris coalesced to form the moon. That violent origin marked the first great impact in the Earth-Moon system, a collision whose effects we still trace today. But the impacts didn't end there. In the moon's early era, the inner solar system was a shooting gallery of asteroids and comets. The moon, lacking plate tectonics or an atmosphere to erase the record, retains almost every major strike in its history. Close-up footage of the lunar surface, craters of various sizes, the South Pole lichen basin. Take a look at the lunar surface. It's peppered with craters ranging from small pits to massive basins, hundreds of kilometers across. One of the largest is the South Pole lichen basin, about 2,500 kilometers across and up to 8 kilometers deep. Wikipedia, this ancient scar formed during the moon's earliest epoch, capturing an era of heavy bombardment. Every crater tells a story: the speed, angle, and size of the impactor, the nature of the surface, the age of the event. Scientists use crater counts and melt rock to date lunar surfaces and map the moon's deadly young years. And because Earth recycles its surface via tectonics and erosion, the moon preserves a record of impacts we on Earth cannot easily access. NASA Science, but what about more recent impacts? Although fewer in number, they still occur. The moon still gets hit, even if the strikes are smaller. These ongoing impacts hold important lessons about hazards in space and for future lunar astronauts. Split screen. Lunar impact simulation. Earth impact simulation. Tidal effects. Impact events on the moon and Earth are linked in surprising ways. The moon's gravitational influence helps stabilize Earth's tilt, moderates tides, and protects us from some impacts by absorbing strikes, acting as a cosmic shield. One large impact on Earth would leave visible scars. Yet because of erosion and plate tectonics, Earth's record is largely erased. On the moon, we see the raw evidence. Imagine an asteroid striking the moon today, vaporized rock flying off into space, ejecta landing back on Earth, a bright flash across lunar horizon. Studies show that lunar impacts can send debris toward Earth, potentially causing meteor showers or satellite damage. Understanding lunar impacts helps us prepare for impact hazards around Earth and for future missions returning to the moon. As we plan bases and colonies, we must consider that the lunar surface is still being shaped by cosmic collisions. Footage of lunar landers, rovers, Artemis mission, simulations of future impact scenarios. As humans return to the moon, impact risk becomes a real concern. Future bases, orbiters, and lunar infrastructure must consider micrometeorite bombardment and larger strikes. While catastrophic impacts are rare, even small ones can damage equipment or send dangerous ejecta. NASA's lunar orbiters continue to monitor the surface, cataloging new craters and tracking impact rates. This information helps engineers design protective shielding and select safe landing zones. Moreover, some scientists have begun modeling how a larger impact, say a few hundred meters wide, would affect the moon. Surface environment, dust lofting, ejecta reaching orbit, and potential hazard for human crews. Every strike carries legacy. Lunar dust kicked up, seismic waves through the moon, remote sensors registering the blast. The moon is not static. It is a dynamic record of impact history, and a space infrastructure must respect that history. Wide shot, moon rising over Earth. Zoom out to the Earth-Moon system in space. Soft music. The moon's surface is a scarred chronicle of a system in constant bombardment. From its fiery birth to the present-day micro-impacts, it tells a story of violence, survival, and change. Understanding lunar impacts is more than academic. It's essential for our future in space. As we look up at that glowing orb tonight, remember, every crater is a snapshot of history. Every shine of moonlight is the reflection of an ancient collision. As we plan to live on other worlds, we carry this knowledge with us.